when we are talking about quadratic roots, those are just the points where the parabola intersects the x-axis. So a root, if I say find the root, I'm asking you where does this point touch the x-axis? I could ask the same question a lot of different ways. When something touches the x-axis, it could also be called a zero, because if it's on the x-axis, then y is equal to 0. Sometimes it's called the solution. I should say zeros, because it could be more than one. So zeros, where it hits the x-axis, solutions, where it hits the x-axis. Last one, x-intercepts. So these 4 words can really be used interchangeably. And we're doing these the exact same way that we have them. We're drawing the graphs, but now I'm going to ask you an extra question at the end. Looking at the graph you just drew, can you tell me what the zeros are, or what the x-intercepts are? And all that's saying is tell me the points where it hits the x-axis. So it is possible to have multiple solutions on these. So something that has 2 solutions, we know we can have parabolas that intersect the x-axis twice. So this point and this point will both be a solution. It's possible that we have a parabola with only 1 solution if it only touches the x-axis at a single point. So something like this. It hits the x-axis, but only at the 1 point. What is the name of that point on this parabola, by the way? The vertex. So if the vertex has a y value of 0, that's going to be it. It's also possible to have no solution. Like if I gave you maybe this parabola. Does it ever intersect the x-axis? No. So we might get 0, 1, or 2 solutions on these. All right. We're going to start out the same way we were working yesterday, with a graph. So the first few, these are in standard form. So we can get our graph. What's the first thing we have to do? We need the vertex opposite of b over 2a. What's the a in this problem? A is just the number in front of x squared, so 1. B is the number in front of x, so that's 4. C, we don't need it, but if I ask for it, is the negative 5. So the opposite of b would be a negative 4 over 2 times 1. Negative 4 over 2 is negative 2. All right, so that goes at the center of this table. I gave you a few more spots than we're used to on this, but we can certainly do it. How do we get the y? Give me 2 different options.
Put the negative 2, multiply it.
Yep. Plug the negative 2 into this equation. Or we're going to the table feature anyway. Can we get the y value from that table? Yes. So go ahead and pull up the table for this. All right. So negative 2 has a y of negative 9. And we'll go ahead and fill in these boxes. So, and we needed more points than usual because the point we are looking for is right here. It's the ones that have a y value of 0. So we need to use the table until we get those points where the y is 0. So then if we graph those. 5, 0. so when I graph my parabola, we can see the solutions, or the points that we're looking for, are where it hits the x-axis. How many of them are there? 2. All you have to give me are the x values. So this is when x is -5, and that's when x is 1. So we can get it by looking at the graph. We can get it from looking at our table. Typically how it's written, so we could say x equals, you might see it written with the solution set, so those squiggly brackets around it. That's just showing it's not order pairs, it's just those 2 numbers. Those are the things that make this equation equal to 0. Let's try another one. Let's go to, do you guys care if I go down to example 3? Okay. So opposite of b over 2a, what's my a?
-1.
And b?
-2.
And c? So the opposite of b would be a -2 over 2 times -1. So -2 divided by -2, which is 1. So that's in the center. Okay, let's get our points. So go into our table feature. We're just going to put enough points down to fill this table up. So if I plot these, -2, -11, does my graph even go down that far? So we can kind of estimate it. -1, -6. 0, -3. -2. What do you notice about this graph?
It doesn't touch the.
It doesn't. Okay, it's going downward and it never hits the x-axis. So what do you think we say? You can say no solution if you want. Just looks like that. Or you could write out in words, no solution. Could you have gotten this from the beginning if you looked at the graphing calculator and looked at the picture of the graph? Yes. And on an EOC, you'll have your graphing calculator. You'll also have Desmos, so you can use those graphs to your advantage. All right, let's try a couple more. Let's do number 4. All right, what's my A?
1.
B?
10.
-10. And C is 16. So when I do the opposite of B over 2A, so B is -10, so the opposite of B is +10 over 2 times 1. So we get 10 divided by 2, which is 5. So that's the center. Seemed like yesterday we're doing good with getting our tables. so we get our graph. When you look at that, can you tell me what the solutions are? Right, you can get it either from the graph, the two places where we hit the x-axis, or looking at the table, the two x's that make your y 0. So 2 and 8. Okay, how are we doing with this? Do we need more problems? Okay, so I'm going to give you a handout. We are not doing this bottom part, talks about discriminant. We are skipping that. So on your handout, you are only doing these graphing ones, so only 1 through 9.